right, last section on this review. So what you're going to do is, it says that the average yearly snowfall in Chillyville is normally distributed with a mean of 55 inches and a standard deviation of 4.83 inches. Illustrate with a picture and evaluate for the following. All right, so first of all, we want to make sure when it's asking for a picture, it's talking about like the little normal distribution graph. All right, cool. So we've got a mean of 55, and then we got a standard deviation of 4.83. So we're going to draw 4.83. So we're going to take 55, we're going to add 4.83. So this is going to be 59.83. And then we're trying to find the snowfall that is less than 60. So that's like, if I'm going to shade, and I'm sorry, it's so ugly. If I'm going to shade, it's going to be below down here, right? That's going to be my picture. So now I actually have to calculate it, okay? So in order to do that, I'm going to take 60 and subtract the mean and put it over my standard deviation. Okay, so I'm going to go into my handy dandy calculator and I'm going to type 60 minus 55, and then I'm going to divide it by 4.83. Okay. Then I'm going to take 1.03 and I'm going to go into my z-score table. I've taken this one from just like the internet. You can pull up a z-score table. Just make sure it's the positive one. And so I'm going to go down to where it says 1.0 and then over to where it says 0.003, which is 0.8485. So this has a 84.85% chance of happening. Okay. All right, so now for this one over here, again, you're going to draw that picture. You're going to say, I'm going to do it in a different color. You're going to say the mean's in the middle, that's 55. And then you want to do that first standard deviation, 59.83. I don't know why I keep writing for 83. And we want to go above 57. So from here, that's about 57 and over. Okay. All right, so on this one, we're going to do the same thing where we're going to take the number 57, subtract 55 from it, and then divide by the standard deviation, which is 4.83. Go into our calculator. We're going to say 57 minus 55 divided by 4.83. And that's going to give us 0.41. So we're going to go into our z-score table. We're going down to 0.4 and over to 0.01. Now, it tells us that it's 65, right? 65.91. However, since we're trying to evaluate above, okay, and z-scores go below, just like what this kind of picture is telling us, okay, then what we're going to do is we're going to say 1 minus 0.6591. So again, go into our calculator, and we're going to say 1 minus 0.6591. And that gives us 34.09%. Okay. All right, so now on this next one, this next one's a little tricky because it's in between two numbers. Okay. So on this one, I'm going to go ahead and erase. You're going to draw your normal distribution. So 55 go here. 59.83 right here. 57 somewhere in between. And then we went all the way down to 31. So subtract here, you're going to get 41. And we're going to go down to, so if I do 41 point, I'm sorry. So we're going to take 55 minus 4.83. And that's going to give us 50.17, right? I'm sorry for writing that incorrectly. So 55, 50.17, and then we're going to subtract again. Okay, so 50.17 minus, 50.17 minus 4.83 is going to give us 45.34. Okay, and we're going to go all the way down to 31. And really that's going to take us to the end, so we don't really have to like draw it completely out, but if you want to and it makes you feel good, all right, cool, awesome. But 57's right here, and then we're going to go over. Look at how messy that is. Okay, so now what you're going to do is you're going to take each of these and perform the z-score. Okay, so we're going to do 31 minus 55 divided by 4.83. Okay, so we're going to go into our calculator and we're going to type 31 minus 55 and divide by 4.83. Now notice how it does give you a negative z-score value, so that's really, really, really important. Okay, and then over here we already calculated this guy, and that's going to give us 0.6591 for our z-score. But remember, we got to use that negative z-score table. I'll pull that up in just 1 second. Okay, so since it's going to be kind of off the chart, because most of your z-score tables are going to only run to negative 3.5, and right now we've got negative 4.96, and look at how it's repeating like at that 0.02. So that's what we're going to assume that our score is going to be. So this is going to turn into 0.0002. And so now we're going to take this, and we're going to take this, and we're going to subtract them, okay? So we're going to subtract them. So we're going to go 0.6591 minus 0.0002, and that's going to give us 0.6589. So that's really 65.89%, okay? And I'm going to erase this in just 1 second. So the last one's kind of like you're working backwards. You've got like the z-score table number, but now you want to know the value of x. So in order to make this happen, it's going from a certain number up to the top part. So for instance, this is going to be roughly in here up above. Okay, and the reason why I know that is because at the mean represents 50% of the data, right? And we want 42.3%, which is above the mean. Okay, so when I actually write this out, I'm going to have x minus 55 divided by 4.83. X is what I'm trying to solve for. But I'm going to set this equal to not 0.423, but actually I'm going to go into that z-score table chart, and I'm going to pull my numbers from that. So if I go in here and I find 4.23 in here, and remember that's going to be, actually it's going to be 0.577, and here's the reason why. All right, we're going to go back. Sorry, it's a little, there's like 14 million tabs. It's actually going to be looking up the number 0.577, because remember, when we do normal distribution and we do z-score stuff, it's coming from the left side. So if we're going from this point up, we're actually doing 1 minus 0.423, which is going to give us that 0.577. So when we go back into that z-score table and we look for, sorry, these are all negatives, no. All right, so we're going to look 0.577, so that's going to be roughly in here somewhere. So it's in between 1.9 and 2.0. So we're going to just say 1.9 for right now. Okay, and this is just going to give us a rough estimate. So when we solve, it'll help us out. Okay, so we're going to multiply by that 4.8 times 1.9. So we're going to get, and so when you go into your calculator and you actually look this up based off of the table, and some tables just vary. try to be consistent, but you know, sometimes it's just tough. Okay, so we're gonna just go with 1.8, 1.08. I'm sorry. Yeah, so let's look at our table again. And so roughly we've got 0.577. Where that falls is in that 0.18 value. So when I go in here, I'm going to multiply 0.18 by this 4.83. Okay, so calculator, I'm going to take 0.18 times 4.83, and then I'm going to add 55 to it, and that's going to give me roughly 55.9, and that's the number that's actually going to make that probability true. Okay, and I know that was a lot of information, but you got to know how to do it. So, all right, so let's look at number 19. Okay, so on number 19, what's going to happen is it says, in their October 2003 issue, Consumer Reports evaluated the price and performance of 23 models of their cordless phones. Computer output gives these summaries for the prices. Were there any of the prices outliers? Explain how you made your decision. Okay, now remember, we do have a formula for outliers, but whenever you want to do these types of problems, you always want to make sure that you draw the box and whisker plot, have that discussion, use the outline. Okay, so I already did my box and whisker plot because they already gave me the information. So now I'm actually going to use my formula for outliers, which is Q1 minus 1.5 of the Q3 minus Q1. Okay, Q3 minus Q1. Yeah. And then I've got Q3 plus 1.5 and Q3 minus Q1. Okay, so that's going to be 30 minus 1.5 times 80. And then that's also going to be 110 plus 1.5 times 80. And that's going to give me 230 here. And then over here, that's going to give me negative. I'm sorry, I'm going to plug this into my calculator. I've got 30 minus 1.5 times 80. And that's going to give me negative 90. And that's like way out there. So is negative 90 less than 15? Yeah. Okay, so there's not an outlier there, right? Okay, over here, 230. 230 is way outside of this 200 boundary. So there are no outliers. No values that are outside of the max or min. Okay. All right, on B, it says one of the manufacturers advertises a cordless phone economy priced at only $31.95. Would you consider that to be a very low price? Personally, $31.95 lies within right in here. So that's kind of like inside of the two quartiles, and at least 25% of the data is less than 31.95. So it's not a very low price. It's kind of like right on par. Okay, so $31.95 lies within two quartiles. At least 25%, and 25% means is like Q1 and above. Or I'm sorry, it's talking about Q1 and below. At least 25% of the data is less than 31.95. And so no, it's not a low price. Okay? And I'm sorry for making this into 4 videos, but it just be like that sometimes.